Hello, everyone. My name is Mete Atamel. I am a developer advocate at Google, based in London. I actually spoke at many Devoxxes before in Belgium, in Morocco. Oops, I start. There's the screensaver. Sorry about that. All right. Well, I'll try to remember not to let it sleep. But this is the first time I'm speaking in Devoxx France, and it's always exciting for me to be speaking at a conference for the first time. Did anyone recognize a discrepancy between the schedule and the actual talk? Anyone? No? Come on, you must have. All right, well, if you look at the schedule, it's two people, me and Nikhil. Unfortunately, Nikhil, he's an engineer in Knative team. He's based in Seattle, but unfortunately he had to cancel last minute because of some issue. So he's not here today. So the bad news is that you're gonna hear me talk more, but the good news is that I can say whatever I want, so we'll see how that goes. All right, first of all, two or three announcements. One, everything that I will show today, the presentation and also the tutorial that I'm going to go through, it's already on GitHub, and this is a QR code. So if you want to get the slides or get to the tutorial, you can do that. Secondly, Knative, it's a new technology, and we are trying to understand what people know about it or what people don't know about it, and also what people do with serverless so that Knative can evolve in a way that meets people's needs. So this is a really short survey. If you have time and if you want to fill it, feel free. And lastly, there is a startups program at Google, 3 different tiers. So if you're part of a startup and you want to get credits on Google Cloud, you can do that. And this is the link for that. I just wanted to mention this because I like to help startups. And if you're part of a startup, I just want to mention that this is available to you. Now let's start talking about Knative. First of all, what is Knative? Knative is Kubernetes-based open source building blocks for serverless. And at this point, you might be wondering, how does this make sense? Because there's nothing serverless about Kubernetes. If you know anything about Kubernetes, you know that it's for scheduling and maintaining and running containers on nodes. And these nodes are very much servers, like VMs or real servers, right? But that's the point of Knative, is that if you want to do serverless kind of workloads on a Kubernetes environment, Knative provides you the building blocks for that. When we talk about serverless, let's first define what it means, because depending on who you talk to, you get different definitions of serverless. But I think when you think about an ideal serverless framework, first, you shouldn't worry about servers as an application developer. Of course, there are servers behind the scenes, but that's not something that you care about. Whereas in Kubernetes, you very much care about the containers that are put together in a pod, and then that are scheduled on nodes, right? So you always think about the underlying infrastructure. But in a serverless framework, you shouldn't really care about that. You want your serverless framework to be idiomatic, meaning if you are a Java developer, you probably want to write Spring Boot application in a serverless way. If you are a C# developer like me, you probably want to use ASP.NET Core Web API. You don't want to rewrite your app so that you can run it on your serverless framework. Serverless is usually event-driven, meaning you have your function and it gets triggered by an event. This can be either a message or it can be an HTTP call, but either way, it's async and it's event-driven. And finally, it would be nice to have your serverless function portable, meaning you write it once, you deploy it to one place, but then if you want to deploy it to another place, you should be able to do that. And that's what containers kind of give us. So Knative kind of does all of these in a nice way, and that's what I'm going to talk about throughout this talk. Now, when you look at Kubernetes, Kubernetes is all about containers. So you start with your code as a container, then you create what's called a pod template, which is a single or multiple containers bundled together. Then you tell Kubernetes what you want to be true. In this case, we are saying, I want to have 3 replicas. And then Kubernetes takes care of that from then on. So it will look at the nodes that you have. So these are virtual machines usually. Then it will figure out where to schedule these pods. And then once pods are running, you would have a service that will expose your pods to the outside world, right? So in this world, you are very much thinking of containers and the nodes, right? But this gives a really nice framework for operators to schedule and maintain containers. So when you look at it, as an application developers, if you're like me, you don't want to think about this kind of stuff, right? Like the nodes, I don't care that there's nodes behind the scenes. Like I want someone else to manage that for me. You just want to focus on your code. Whereas operators, they like to use Kubernetes because it gives them a high-level API to manage their infrastructure, right? So there's this tension between serverless people, who are usually application developers, and operators. And Knative tries to bring those two worlds together, basically. It's an open source project that started from Google, that came from Google, but now a bunch of other companies like Red Hat and IBM, they're contributing to it. And it's basically a set of components that you can take and install on top of Kubernetes so that you can run serverless workloads on top of Kubernetes. So these components, there's serving, eventing, and build that we'll go through. And it basically comes from Google's learnings of running this kind of workloads internally and learning from it and then exposing it as an open source project. Now the Knative stack kind of looks like this. And by the way, the latest version of Knative is Knative 0.5 that just came out last week. So I had to update some of this over here, and I also had to update my tutorial as well. So we'll see if some of the things still work. But one thing is that first, everything runs on Kubernetes, so that's the underlying stack. On top of that, you need some kind of gateway. Now, up until Istio 0.5, up until Knative 0.5, Istio was the only thing that was available. So you had that dependency on Istio. But now there is something called Glue that anyone use Glue here or know what it is? Okay, one person. I don't feel so bad then. I never use Glue, but apparently it's an API gateway. Now that's also an option. So you can use that as an API gateway under Knative. But when you use Glue, you don't have Knative eventing yet, right? That's not supported yet. So just you need to keep that in mind. And you might be wondering, like, why do we have support for both? What's the difference? Well, Istio is a more fully fledged way of managing your traffic, but it's kind of heavyweight. So there's a lot of parts of Istio that you might not need. Whereas Glue is much more lightweight. So I think that's why most people, they kind of prefer the lightweight version of Istio, and that's why there's support that's being added for that. Okay, so we have the dependencies of Kubernetes and Istio, or gateway, and then on top of that, you install Knative with build, serving, and eventing components. You can install all of these components together, or you can install them one by one, depending on what you need. And finally, on top of Knative, there's actually products that are being built as well. So if you follow Google Cloud Next couple of weeks ago, we announced Google Cloud Run, which is a way to run containers in a serverless way. And we also announced Google Cloud Run on GKE, which is Google's Kubernetes engine. So these are actually built or use some parts of Knative, right? And there's other companies that are also building on top of Knative. So that's the idea of Knative, is that it has some dependencies, it provides some components, and then the tooling on top of that is coming from different companies in terms of different products, right? Yeah, and this is what I mentioned. So if you want to do serverless on Google Cloud, first, you can use Knative, and that's what I'm going to show today, running Knative as is, without any dependency to Google Cloud. So you can do that as long as you have a Kubernetes cluster. But if you have a Kubernetes cluster in Google Cloud with GKE, then there's something called Cloud Run that basically runs Knative for you on GKE. And then there's another version called Cloud Run, which is basically a version of Cloud Run that runs on Google's infrastructure instead of GKE, right? So these are the options that you have, but today we are focusing on just the open source part, just Knative, so it will work on any Kubernetes cluster that you have. All right, so what do you need to do to get Knative going? First, you need a Kubernetes cluster. In Google Cloud, you would have a single gcloud command line tool to create a cluster. So that's what I did here. Then we need to install Istio on top of that. And before I install Istio, I need to create what's called cluster role binding. This enables Istio to manage the traffic of the cluster. And then I install Istio, which is my dependency for Knative. And then I install Knative serving, build, and eventing all at once, right? But as I mentioned before, you can install them separately as well. So it's basically installing the dependencies and then installing the components of Knative that you need. All right, I already have this set up, so let's just make sure that things are working. Let's take a look. So here I am in Google Cloud, and if I go to Kubernetes engine, you see that I have 2 clusters. This is an older version that I have, and Knative 05 is the 05 version that I already installed with Istio and everything. And let me just make sure that things are running. So what I'm going to do is I'll just say kubectl get pods. Let's look at Knative serving first. So if everything is installed under separate namespaces, so the Knative serving pods are running. Let's look at eventing. The eventing pods are running as well. And then let's look at build. And the build pods are running as well. And I'm going to show more stuff later. So everything is running. Now, first, let's talk about Knative serving. What is Knative serving? It basically allows you to rapidly deploy your containers in a serverless way. And what I mean by that is you basically create what's called a Knative service. You point to your container, and then you just tell Knative deploy this container. And then out of the box, you get that container deployed. All the traffic to that container is hooked up because of Istio. And then you also get automatic scaling. By default, your service, your container will have 1 pod, so it will run on 1 pod. But then if more requests come in, it will auto scale to max value that you define. And if no one uses it, it will scale down to 0 as well. So that's what you usually expect from serverless, is that things scale up and down in a seamless way. And that's what you get with Knative serving. On top of that, you get what's called configuration and revision. So your service has a configuration that you can define. And every time you change the configuration, Knative creates a new revision. A revision is kind of like a snapshot of your configuration. So you get that. And once you have multiple revisions, then you can set rules on how the traffic is routed to different revisions. So you can say the latest revision gets all the traffic, or you can say the latest 2 revisions gets 50% of the traffic, and the other one gets the other 50%. So that's what you get, basically. Deploy your container, get traffic routed to it, get auto-scaling, get configuration and revision management, and get traffic management on top of that. And these are kind of the building blocks of Knative serving. So you first start with a service. This is not a Kubernetes service, by the way. This is Knative service, so it's something separate. And then your service will have a configuration. And then from the configuration, Knative will create a revision. And then if you are using the run latest mode, then there will also be a route that will be created. And the service will route all the traffic to that revision. Okay? And every time you change something about the configuration, the revision, a new revision will be created, and the route will be updated to that revision. So that's the way it works in Knative. Let me show you this. So as I mentioned, I have this tutorial on GitHub where I have these slides, and I also have Knative serving, Knative eventing, and Knative build that you can try. So I'm going to go through this, some parts of this tutorial in this presentation. So first, let's look at Hello World serving. What I do here is that I want to just expose a simple container on Knative and see what that looks like. First, what you need to do is you need to write your code and deploy a container. In this case, I'm using a ASP.NET Core application because I'm a C# developer. But if you're a Java developer, you would use Spring Boot, and basically you will have a container and push it to Docker Hub. So once I have the container, I need to define my Knative service. First, one thing to notice is that the API version is Knative, so this is Knative API, and the kind is service. You can give your service a name. In this case, I'm calling it Hello World C#. And then under spec, this is where I define my service configuration. First thing that you'll notice is that it says run latest. This basically says when you deploy the service, route the traffic to it. So it will get all of the traffic by default, right? That's what I'm doing here. And then the configuration is basically any kind of configuration that you want for your service. So I'm pointing to an image that I already have on Docker Hub, and I'm also passing some environment variables named target, and the value is C# sample v1. And I'm going to print this out as a way to see that my app is deployed, right? So we apply the service, and then let's actually take a look at these. So let me just copy this, and let's watch them here. So right now I have 3 pods running. These are things that I have for later. So you can ignore them for now. But if we look at the serving, and if I go to Hello World C#, and let's just apply service v1. Now we applied it, and immediately what we're going to see is, actually it's not easy to see. So what I'm going to do, let's try again. Maybe make this a little bit bigger. Yeah, so what we have is that first, I have a pod that's been created for Hello World C#. Then I have a service, this is a Knative service that's been created. Then I have a configuration object that's been created. Then I have a revision object that's been created that says generation 1, meaning this is the first revision. And I have a route that's also been created that's pointing to my service. So all the things that I talked about, they're already been created. Now, normally, so once you have this, if you want to test this out, everything is behind Istio, because Istio is the one managing traffic. And Istio has something called Istio ingress, which is basically a public external IP. So normally you would just curl that external IP, but you need to tell Knative which service you want to hit. So you pass this header, and you say, this is the name of my service, this is the namespace that it's in. So in this case, it's default. And this is the example domain that Knative has by default. So normally you would do this. But if you configure your domain, which I did here, and I explain how to do this here, but I won't bore you with the details. What you can do is you can basically just curl directly to your service. I'm using something called nip.io. It's a dummy DNS service that I use so that I don't have to set up a real DNS. But basically what you can do is that you can have things like this, like with the ip.nip.io, that can map to the actual IP. So I set this up this way. And then what I can do is that I can just, let's copy this. If I do here curl, and I think, yeah, it says hello C# sample v1. It's not that exciting, but at least we prove that everything works. Now, as I mentioned, every time you change something about your service, it creates a new revision. So let's take a look at one of that. For example, in this version 2, what I'm doing is that I am using the same image, but instead of having version 1 in this value, I'm having version 2. So I'm just changing the value of my environment variable. So if we deploy this, you will see that immediately Knative creates a new pod, then service, it's still the same service. It's still the same configuration, but the revision is updated. Now we have a second revision, that's generation 2. So a new revision is being updated, and we can't see the route, but basically the route is also updated to point to the new revision. So if you do curl again, now it says v2 because it's going to the new revision. And similarly, if you want to change the code, let's say you change the code and you want to update your service, you go through the same process. You create your new image, you push it out to Docker Hub, and then you change the configuration. So let's take a look at that one. In this case, yeah, I created a new revision where instead of saying hi, I say bye, and then I call this version 3, and then the image, now I change the image to point to this new version. And once we apply this, again, it's the same thing. It will create a new pod and a new revision, and the traffic will be updated right away. Now we updated the code. So if I do a curl, you see that it's my new code that's being called. Now, maybe you don't want this all the time, because sometimes when you deploy your code, you want to test it out before you roll it out to people. So Knative also supports traffic splitting. So you can split traffic between different versions. In this case, for example, let's say you want to create a new revision and split the traffic between the existing revision and the new revision 80% to 20%. So the old revision gets 80% of the traffic, and the new revision gets 20% of the traffic. To do that, what you need to do is you update your service, but instead of run latest, you will say release. So you're saying, I don't want to update my code to latest version. I want to do a release where I define the percentage. And in this case, we are referring to revisions. These revision IDs, 1 and 4, they're not real yet, because the revision IDs, when I show you Knative, they have like a hash code. But what I'm going to do is I'm going to deploy this first and then update them to the real values. So I have 2 revisions, and then 20% means, so this one, the first one will get 80% of the traffic, the second one gets 20% of the traffic. So that's what you're saying here. And this configuration is the configuration of the new version. So it's the configuration of this one. So here I'm saying I'm going to use the same image, but instead of saying V1, I'm going to say V4. So that's my new revision. This is a little bit confusing, and they're trying to make this a little bit easier in the next release. But as of today, this is what you need to do. So first, let's apply this. Service V4. And now, if you look at the revisions, these are actually the real revision ID. So this is the first revision. So let's copy this and actually go to my service v4 and replace this one. So this is my first revision that I need to use. And then this 4th generation is this one. So I want to split traffic between those two, right? Oh, I didn't copy, I guess. Let's try again. Okay, and let's apply this again. So now I'm actually doing it. So in the first apply, I created a new revision, revision 4, and now I'm updating the configuration to do the actual rollout to 80% to 20%. So let's do that, and in the meantime, let's do some curl commands so we can actually see this. So let's do this. And if we do this, now, by the way, one thing that you realize is that the pods, they come and go. Like if you don't use them for a while, then they sleep and you don't have any pods. Then if you use them, they wake up. So in here, most of the time, 80% of the time, we are getting V1, but 20% of the time we get V4. So that's how you can do traffic splitting between an old revision and a new revision. You can also do traffic splitting between 2 existing revisions. I won't show this in demo, but I'll just show it here. So basically, you update your service, you say release again, and then in the revisions, you just point to 2 revisions that exist already, right? And then once you apply this, these 2 revisions will get 50% of the traffic, okay? So that's Knative serving, and the last thing that I wanted to point out here is that the auto-scaling, I mentioned scaling down to 0, scaling up, it's configurable. So the default one, the default auto-scaling is something like this. It's a concurrency-based auto-scaling, meaning each pod will get 100 requests in flight by default, but you can change that. You can make this 1 if you want to test out auto-scaling. You can also do other kinds of auto-scaling, like if you want to do CPU-based auto-scaling, you can do that as well. You can even write your own auto-scaling, so it's pluggable so that you can write your own auto-scaling as well. And also the min and the max is configurable. So if you want to not scale down to all the way to 0, you can set this min scale to 1, and this means that you will always have 1 pod running at all times. And you should always set a max scale as well, because you don't want to scale up infinitely, right? So that's how you do auto-scaling. I'll skip this in the interest of time, but it's part of the tutorial, so you can go through it if you want. And you can also use Knative serving for more interesting things. You can basically integrate it with any external system, and that system can actually call your Knative serving API, because Knative serving is as long as the URL is public, anyone can call it. So I tried to something like that. For example, anyone here used or knows Twilio? Anyone? Yes. So Twilio is a really nice framework, I guess, for building voice or SMS applications. So you can have a virtual number, and people calling that number can basically get triggered to your code. So you can basically say, if people call me on this number, I want this endpoint to be called. Or if people send an SMS to this number, I want this endpoint to be called. So you can do stuff like that. So I just wanted to see how I can set Twilio messaging so that it calls my Knative service. So the way this works is that from my phone, I send a message to my Twilio number. And then from Twilio, I set an endpoint, like a webhook endpoint to my Knative serving. So Twilio calls my serving, and my serving does something. In this case, it basically just echoes back the message, and it sends that SMS back to the user using Twilio API. So to do this, I'll show you the code briefly before we actually deploy it. So I have a controller, SMS controller, that basically gets an HTTP request. So this is coming from Twilio, and I'm using Twilio's NuGet packages. And once I get an incoming SMS request, I create a response. And in the response, I say Knative copycat says, and I just echo back what the user sent. And then I just use, again, Twilio API to send that request back. So this is very simple code to basically reply back to the user. So to deploy this, I will show in here. First, we need to create, again, like a service. I show you the code already. And we push the image. But the service is basically like this. It's just like before, except I'm pointing to a different image. In this case, Twilio C# v1 client. And then I need to go to Twilio console and point to my ingress IP /SMS so that I can get to my SMS controller. So let's try that out. Let's see. I need to be in Twilio, kubectl apply, service. Now this creates the Twilio pod and the Twilio service. You see that it's a new service. And if I look at the Twilio console, this is my console. By the way, this is my UK number. Feel free to send messages. It just replies back. But the important thing is that in configuration page for this, I am saying if I get a voice call, make a call to this endpoint, which is a demo account of Twilio, so I'm not doing anything specific here. But for messaging, I'm saying make a call to this nip.io endpoint /SMS. So this is my Knative service that's running, right? So let's try this out. What I have here is that I'm looking at my SMS messages in the browser, and this is my Twilio number. And as you can see, well, it says connecting. Let's see how that's going to work out. But as you can see, I tried before. Hello from Paris. Oh, not connected. Yeah, sorry. With the Wi-Fi's and everything, sometimes, oh, my phone is not connected. Let me connect my phone. Yes. It should come back. Yep. And then let's just say, hello from Devoxx, France. So I send this. It goes to the Twilio. Twilio says, OK, let me call the webhook. Webhook is a Knative instance. It runs my code. And then my code just says Knative copycat says, hello from Devoxx, France. So you see that how easy it is to basically integrate with whatever you want. As long as you have a public endpoint, things just work. All right. Now that's serving. Next, let's look at eventing. So what is eventing? Basically, I mean, we all know what eventing is from other things like JMS and all the messaging frameworks. But basically, eventing allows you to connect event sources to event consumers and have some kind of flow in the middle that you can define. And that's what Knative is. The nice thing about Knative is that you can declaratively define like how things are connected. So everything is YAML-based. So in the YAML, you can see who's connected where. And it's using something called cloud events. So this is a CNCF definition that Knative relies on for events, so for sending and receiving events in a generic way. Now, before 0.5, so up until 2 weeks ago, this is how Knative eventing looked like. So what you would have is that you would have a Knative source that will listen for a source that you define. For example, if you want to listen for GitHub events, this source will listen GitHub events and will receive them. Then it will save it to something called channel. Channel it can be an in-memory channel or it can be a durable channel. And then people who are interested in those messages in the channel, they subscribe to it. Just like JMS, how we are used in JMS, a service can subscribe to a channel, another service can subscribe to a channel, and then you can also chain these channels so that once you process this message, it can go to another channel where other services can also subscribe. So that's how the model was, and that's what I'm used to, and I kind of know the details of these. But then in 0.5, they changed it all, and it kind of looks like this. So source, we still have the sources. It's pretty much the same. But then the messages go to a broker. So broker is kind of the thing that listens for the messages for Knative. And then you also define what's called triggers. So what happens after broker? You basically say, okay, when you receive this message, trigger this, which can call a service. So that's kind of the flow. So from the source to broker, broker to trigger. In trigger, you can have filtering, so you can filter some of the messages, or you can just send all the messages to service. Now, what's not clear to me is the relationship between channels and subscriptions and brokers and triggers. Yeah, I went through the Knative docs and the code and everything. It kind of looks like they're kind of similar. So some of it may be rename, and some of it might be like they basically try to make this more higher level abstraction, and under the covers they're still using subscriptions and channels. But I haven't figured that out yet because this is just new. But once I figure it out, maybe you can see one of my talks later where I explain that. But as of today, basically you need to create a broker and trigger to connect different services. And there's a bunch of event sources that's already implemented in Knative. So for example, if you want to listen GitHub events, it's already there. If you want to listen Kafka events, it's already there. There's an event source for that. And what we're going to look at is Cloud PubSub. So GCP PubSub, it's a global publish subscribe messaging system in Google Cloud. You can listen to messages from that as well, and that's what I'm going to show here. And these event sources are kind of, you can write them yourself as well. So if you need to listen from somewhere custom, there's an API, and you can implement it yourself and run it yourself. All right, so let's look at some examples of this. So go back to my tutorial. So again, let's start with Hello World eventing, and I mention what the broker and trigger is, and talk about the old system. So I already set up the broker, and I already created the source. So the broker and the source that's in front of it is already created. Let's just make sure that the broker is running. Yeah, so I have a default broker that gets injected into the default namespace. So you can inject brokers into different namespaces. In this case, I just injected one to my default namespace. Then I created another Hello World sample, and what I do is, once I get a message, just log it out. Just log that message out so we can see that it's working, right? Nothing exciting. I built and pushed the image. Then I create a trigger. So this is how you connect your service to your event source. In the trigger, the first part is a service. So this is just a regular Knative service. And just like before, except I point to a different image. And I also set minimal scale to 1 because I want to make sure this is running at all times. So I always have one pod running. And then I also define a trigger. This is the thing that basically connects my broker to my service. So that's how you make the connection. Right? So once we apply trigger, we can test this out. So let's just let's do that. I need to go to eventing. So in eventing, there is a PubSub source YAML, this one, that basically sets up my source with GCP PubSub. I won't show you the details of that, but that's what you need to do initially. And then I can go to message dumper, and then in here, let's just say kubectl apply trigger, and we can get out of this. So this creates the service and also the trigger. And if you look at the pod, you can see that there's a message dumper already running. And what we can do is we can actually look at the logs of that pod. So let's just copy this out. And just copy this pod ID. Now it's waiting. It's a Knative service waiting for messages. Then I can send a PubSub message. There's many ways of sending PubSub messages to Google Cloud, but one thing that you can do is you can use gcloud command line tool to send it. So let's just copy that out. I never remember this command, so I had to come back here. So here what I'm doing is I'm saying gcloud PubSub topics, publish a message to this topic called testing, and my message is hello world. So let's send that out. This will go to PubSub. Then from there, an event source will listen for it in Knative. They will send it to broker, and from broker, it will go to my Knative service. And the Knative service says, I received this message with this ID and data, and this data is base64 encoded. So let's decode that. If I remember the syntax, it's like this. No, it's like this. Yes, It says hello world. So we made the connection. This is not too exciting, but you can extend this and you can combine things that are completely unrelated. For example, I'll show you one. I have this sample where you can connect Google Cloud Storage to Vision API. So first, there's this thing called Cloud Storage, where you can save any kinds of files. So you just create a bucket, and you can save any kind of files. Then you can create a notification on the bucket, meaning every time someone creates a file or deletes a file, you can send a notification that goes to Google Cloud PubSub topic that you define. And then you can make Knative eventing listen for those messages, right? Get it from PubSub, and then pass it to Knative serving, right? And then from Knative serving, you can do whatever you want. In this case, I'm calling Vision API, which is a machine learning API to detect images. For example, you can pass in an image, and it can give you the labels of those images. So here we will pass in the image information, and then Vision API will give us the labels, and then we can log that out, or we can send that information to the user somehow. In this case, I just log it out. So what we are doing is that we are combining, we are kind of gluing the cloud storage and Vision API together using Knative eventing. Now, all of this runs in Google Cloud, but it doesn't have to, right? The Knative part can run anywhere, and that's the key thing about Knative, that it can run anywhere. So let's take a look at this. So I also have another sample for translation API, but we'll skip that. So Vision API, so what I do is, again, create my code. What you're going to get is cloud events. So that's how you receive events in Knative, and you need to parse that out. So what I have here is that I basically get the message and parse out the cloud event from it. Then, yeah, so I get the cloud event out of it. Then I need to look at the event type. So when you save an image to a bucket, the event type is object finalize, right? So I'm looking for object finalize events. And then from cloud event, I can get the URL of the image, basically. So that's what I'm doing in this function, is that I get the bucket ID and the object ID, and from there I construct the URL. And then finally, I can call the Vision API. So what I do is that I create a Vision client, which is a client to talk to Vision API, and I just say detect labels async. So I just pass in the image URL and say, can you extract the labels out of this image? It will get a bunch of labels, well, not bunch, but 10 results that I specified. So we'll get 10 maximum results. They will each have labels and scores, because depending on how confident the Vision API is, it will have some scores attached to the labels. I order them by score, and I just display them out, right? So I push the image, then I create a service and a trigger, just like before. And yeah, let's try it out. Vision, kubectl, apply. Oops, sorry, trigger. So yeah, the service and the trigger is created, and I have my Vision pod running. Let me look at the logs. By the way, this is how you create a bucket and enable notifications on that bucket that I already did. And let me just copy this. Oh. So now the service is waiting for the message. So what I'm going to do is now I'm going to save an image and see what happens. So let's go back to our console. If I go to Google Cloud Platform Storage, I have this Knative bucket. That's where I have the notifications enabled. I will upload a file, and I will put this beach picture. Anyone knows where this is, by the way? Any guesses? Where? What? No. All right, it's Rio in Brazil, and it's one of my favorite places. So that's why I use this image. So let's send this out. The image is being uploaded. It goes to storage. Storage sends a notification to a PubSub topic. Knative listens to the topic, gets the message, sends it to Knative serving, and Knative serving will make a call to Vision API and extract the labels out of this image. In the end, and that's a lot of back and forth, but in the end, this says, this picture is labeled sky, body of water, sea nature, coast, water, sunset, horizon, cloud shore. Yeah. So that's it. But I guess the important thing here is that you be connected to the things that are not related at all, like storage to Vision API using Knative. All right, I have 5 minutes that I want to show you one more thing, Knative build. But before I talk about this, let me kick off a couple of builds, and then I will talk about it, and then we can take a look at it. So what I'll do is I'll go to build. I have 2 builds. I'm going to apply them, and I'll talk about them shortly. So one for Google Container Registry, and another for Docker. Yeah, so the builds are running. Let's talk about it, and then we can go back. So what is Knative build? It basically enables you to go from source code to a container image in a repository, right? That's what it is in the end. It allows you to build pipelines, so you can have multiple build steps chained together, and it lets you build container images without having to have Docker locally. There's some primitives. Build is basically one or more steps that you can define in order. You can take a build and define a template out of it so that you can use it from multiple places. There's different builders to build different things, like a container. And finally, if you need to authenticate, you can use a service account, which is a Kubernetes construct, but you can refer to that service account from Knative. So that's what it is really. It enables you to go from your source code to a container. And what I want to show you here is just a couple of really simple builds. So first, I want to build a simple app and push it to Google Container Registry. Google Container Registry is basically kind of like Docker Hub, but it's internal to Google Cloud. And the nice thing about that is that you can have it so that it's anonymous, meaning you don't need to authenticate with it. You can just, anyone can push to it if you want, if you can set it that way. So what I did for this case is that I created a build hello world C# gcr.yaml. And in here, I'm defining a build. And then I'm pointing to my source with the URL and the path. And then you can have multiple steps, but in this case, I only have one step that says build and push. And then I'm using Canico, which is another open source tool to build container images within your cluster. So the pods in your Kubernetes cluster will build the images and push them out. And I point to my Docker file, and then I point to my destination, in this case, gcr.io, which is Google Container Registry. So you do that, and you applied it like we did. Then you can look at the build, you can look at the pods, and if you follow the logs of the pods, you can see what's happening, actually. So that's how you can set up a really easy build. For Docker Hub, it's a little bit more complicated because you need to authenticate. And to authenticate, first you need to create a secret. So this is base64 encoded username and password for your Docker Hub account. So you create the secret in Kubernetes. It's a Kubernetes construct. And then you also create a service account, which is another Kubernetes construct that points to that secret. So this service account points to this secret that we just created. So that's how you create them in Kubernetes. Then you design your build. And this build is exactly the same way as before, except I'm pointing to a service account, right? And the service account knows how to authenticate with Docker Hub. And I'm also pointing to a different destination. So it's docker.io, right? So once you apply this, and let's look at our builds, see if they are done. So if I do kubectl get build, I have my builds. And let's look at the pods. So if I look at the pods, you see that they're completed, both of them. And if I look at the container registry, this is my container registry. You see that 1 minute ago, there was a container that was pushed with the tag Knative build. So that's my Knative build. Similarly, if I have, I have the Docker Hub. If we refresh this, we see that a minute ago, something was pushed as well. Okay, so that's, I think, all I have. Thanks very much. There's a new Knative website that was just released. So if you want to know about Knative, go to knative.dev. My tutorial is here. I only had 30 seconds, so I don't think we have time for questions. But there's a Google Cloud booth here towards the back. I'm going to be there in the afternoon, so feel free to stop by and ask me any questions you want. Thanks very much.